Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ammar bin Zainal and I will represent our group. And our group members is Muhammad Daniel Mukris, Muhammad Azhar, Muhammad Iqbal and Muhammad Fakif Akmal. So for my part, I will explain or give an introduction for our project. So our project name is Hydroelectric System Control. So before we go more further, let me explain what is hydroelectric. Basically, in this other world, hydroelectric power takes advantage of gravity and the natural flow of water to spin the turbines, which are connected to generators. So then the generators produce electricity, making it one of the most sustainable and environmentally friendly sources of energy available today. Unlike fossil fuels, hydroelectric systems do not emit greenhouse gases during operation and can provide a constant energy supply, especially in regions with stable sources. So basically, this project explains how hydroelectric turbines work by combining simulation, coding and IoT monitoring in Proteus. So we go for the next part.
So, next I will explain to you about the system operation for our assignment. So this is the main idea. So the main idea actually is because of the different temperature in the river. So change in the river temperature can cause uneven expansion in a dam structure or construction. It will potentially leading to cracks and long-term damage. Monitoring water temperature is important to maintain the dam safety and stability. So as we know, the minimum height of a dam was 15 meters and the maximum can go up to 150 meters. So because of this, because of the height of the river and the dam, it will make the different temperature in the water, in the river, So the surface of the river will become the hot water and the bottom of the river will become the cold water. Because of the drastic different temperature, it will cause or it will affect the dam structure. So it will due to the cracks or the break of the dam. So because of that, it will make the industry or the house around the area of the dam, it become flood and maybe it will affect all the community around the dam. So because of that, we come with the idea which is the circuit idea. So for the circuit idea, we using MATLAB to interpret our idea, which is we have the Arduino and then we have 3 input and 3 output, which is the 3 input we have the temperature sensor, we have the resistor, variable resistor, and the last one we have the circuit breaker, which is the push button. And then the 3 output that we got, actually the first one is 7 segment, actually to control the speed of the motor. And then we have the DC motor to control the water turbine at the dam. And then the last one we have the buzzer to alert the engineer or the technician the motor are running. Okay, so if the water temperature exceeds 30 degrees, it sending a signal to activate the turbine motor, starting the power generation. When the temperature return to safe level, the system automatically stop the motor. So it will cause the feedback of the loop. It will protect the dam from the thermal stress and then maintain the safe operation. And then the last one, ensure efficient energy generation. So because of this, it will make the dam last longer. So because what? The maximum mostly if this thermal sensor or this thermal concept are not applied, the dam can last lasting until up to 10 to 15 years. But if this concept can be applied to a dam, it can last long up to 30 to 40 years. So it will save more cost and it can save more life. So I think that's all for my part. We'll go to the next part.
Okay, now I would like to explain about our flowchart in this project. Okay, first of all, we need to start the system, and the system will measure water temperature. If the temperature is above 30 Celsius, it will active the buzzer and DC motor. After that, it will read potentiometer input and make values of 0 to 255 PWN, and after that it will display 1, 2 or 3 on 7 segment display based on motor speed. Lastly, the motor will off and stop. If the temperature is below 30 Celsius, it will repeat the system. Thank you. Now
So I will continue the presentation with the explanation of the circuit diagram that we use in our assignment. So at the left side, you can see that this is the circuit diagram that we use in our assignment. So basically, there are 3 input and also 3 output for the circuit. The input that we use is the temperature sensor, potentiometer, and also the switch. For the outputs, we use motor driver, 7 segment display, and also the buzzer. So for the next one, I will explain simply but understandable about the components that we use in this assignment. So first, I will say about the LM35, which is the temperature sensor to detect the water heat. And the second one is the potentiometer, which is to control the motor speed. The third one is DC motor, which is to represent turbine rotation. For the next one, we have buzzer for overheat warning, and also the 7 segment display with BCD 7448 decoder to show motor speed. And after that, we have L293D, which is the motor driver to power the motor safely. And we have also the SPST, which is the push button for emergency stop. And the last one is the virtual terminal that we only get it from the Proteus, which is it used to monitor serial communication during simulation. So I will continue to explain about the test program. So basically, this Arduino program is designed to monitor temperature using an analog sensor connected to pin A1. When the temperature is 30 degrees Celsius or higher, the system triggers a buzzer alarm and activates a DC motor. Then the motor speed is controlled using a potentiometer connected to A5, and the speed level is displayed using a 7 segment display controlled via BCD inputs, which is pin 7, 6, 5 and 4. Then the system has 3 main features, which is the first one is temperature monitoring, which is it continuously reads temperature in Celsius and displays it via serial monitor. And the second one is buzzer alert, which is activates a dual tone buzzer alarm if the temperature is 30 degrees Celsius or higher. And the last one is motor control and display, which is adjust motor speed using PWM and display speed level from 0 to 3 based on speed range using a 7 segment display. So at the right side, we can see the picture for our coding. So basically, this coding is about the declaration about the pin for every component, and also the coding for the temperature sensor. And then for the next one, I will say at the left side, we have the coding for the buzzer, and at the right side, this is the coding for the motor, DC motor, and the 7 segment display.
So my part is simulation and result for this assignment. Okay, so firstly, I want to introduce our equipment in this assignment. So firstly, I use sensor temperature to monitor the temperature in the motor. and then I connect sensor temperature in pin A1 in Arduino TP, and then I use potentiometer to control the speed of motor, which is the speed can appear in 7 segments, and I connect it in pin A5 in Arduino TP. So we have a motor driver, and then we have a DC motor. So I connect it in pin digital 10 and 9 in Arduino TP. So I use 7 segment, which is 7448, and I use also green LED cathode 7 segment, and I use virtual terminal to appear the sensor temperature after I run the project. So I use buzzer as the output. So we have 3 input, and then we have 3 output, which is input, 2 analog input and 1 digital input, which is switch as a circuit breaker in motor, DC motor, and then 3 output, which is 1 PWM, which is will control the motor, and then 7 segment digital output and buzzer digital output. So let's run the simulation. Okay, so I increase the sensor temperature in 28. So when I run, the buzzer and the motor will not on, because the temperature is below than 30 degrees Celsius, which is 28 degrees Celsius. So when I increase to 30 degrees Celsius, the buzzer will on and the motor will run, and I will control the speed of motor using potentiometer, and the speed will appear in 7 segments, which is 0 speed, 1 speed, 2 speed, or 3 speed. So let's increase the sensor temperature. This is a 29, and the virtual temperature will appear 29.30 degrees Celsius, and I increase it in 30 degrees Celsius. So, as you can see, when I increase the 30 degrees Celsius, the buzzer will on and the motor will run. And then after I decrease the degree Celsius below than 30, the buzzer will stop and the motor will stop, which is the number of motor will decrease slowly until 0 RPM. So that's all our result and simulation, and thank you very much.
So now I would like to do a conclusion. Okay, for the conclusion, the use of a temperature control system in hydraulic dam is highly effectively for protecting the structural integrity of the dam, enhancing operational safety and increasing overall energy efficiency. By continuously monitoring the water temperature, the system can detect where it exceeds a critical threshold, typically 30 Celsius, and automatically active the turbine motor. This not only facilitates the efficient conversion of water flow into electricity, but also help reduce thermal stress that could weaken the dam structure over time. Once the temperature returns to the safe range, the system automatically shut down the motor, forming an intelligent and responsive feedback loop. This level of automation minimizes the risk of human error, ensuring consistent and accurate operation even under extreme weather conditions. Moreover, the proactive management of temperature contributes to the long-term sustainability of the hydroelectric facility, reducing maintenance costs and extending the life of equipment. Ultimately, such a system plays a vital role in protecting nearby community from potential hazard like structure damage, overflow or flooding, while also supporting reliability and eco-friendly. That's all from me. Thank you.